Okay, so we're thinking about how to represent numerical expressions. Expressions like 2 plus 3 times 4, or 2 plus 3 times v, where v is a variable. So the simplest possible representation would be a string. We can write the string 2, open bracket, 2 plus 3 times 4, close bracket. And that looks just like the expression itself. But that's a bad idea. Why? Well, because what it doesn't do is represent the structure that we see inside that expression. We see it's an addition of 2 and 3 times 4, and we see that 3 times 4 is itself a multiplication. So there's a structure there. Whereas what we see in the string is a parenthesis and a 2 and a plus and a parenthesis and so on. It's just a sequence of one character after another. Whereas in fact, there's that structure that we see through the string to the structure. So how can we represent that directly inside a program? Well, let's try and visualize what that structure looks like. And what we can draw, at the top level, what we have is an addition. So we can draw it as an addition at the top, and then on the left and the right are the two components that are added. So on the left we have the number 2, and on the right we have a multiplication. And itself is a structure multiplying the numbers 3 and 4. So there is a much clearer representation of what's inside that expression than the simple sequence of characters. So that's what we want to represent in Erlang. And how can we do that? Well, let's just color code the tree that we saw already. We'll use red to represent the addition bits. We'll use green to represent the multiplication bits. And we'll use purple to represent the numbers that are in there. And what will that look like inside Erlang? What it looks like is this tuple. At the top level, it's a tuple beginning with add, says it's an addition, and then it has two other components. The first represents the first sub-expression, the second represents the second. So the first says, it's a pair that says it's a number, and the number is 2. And the second, the final piece of this top-level tuple, is itself a structure. It says, I'm a multiplication. You can see the atom mul there, and then two other fields saying there's a number 3 and a number 4. And you can see the color coding here. At the top level, you've got this red tuple. Inside, you've got the green tuple. And at the leaves, you've got these purple numbers. So that's the way that we represent that particular expression inside Erlang. What about in general? How can we describe what all the expressions look like? Well, what we can do is give a type declaration. We can say what the type of expressions looks like. And what this says is that there are 4 different alternatives for what an expression looks like. They're each a tuple. The first one says it's a pair that begins with the atom num, says it's a number, and is followed by an integer. The second begins with the atom var, and then it has another atom, which is the name of the particular variable we're talking about. And then the third and fourth are the tuples that represent structure. We have an add tuple, and the two components of the add are themselves expressions. So what we're saying here, we're writing a description of an expression that refers to itself. We're saying an expression is built by adding 2 other expressions or by multiplying 2 other expressions. So we've got recursion inside the type. And what we'll see is that this type provides a template for defining functions over this type, which will manipulate expressions, which might print them out, which might compile them, which might evaluate them, and so on. So writing that type down gives us a very clear description of what all the expressions look like, and gives us a pointer to what functions should look like over expressions. So, before we go any further, before we start actually making any definitions, there are 2 other sorts of things we can do with expressions now. Now we've decided to represent expressions as these structures, there are 2 other obvious operations that we might make. We might want to convert from a string to an expression, so we might want to dig out the structure from inside a string, and that's called parsing. We also might want to go in the other direction. We might want to go from a structure, this string that's a tree, to a printed version that's perhaps easier to read but doesn't have the structure there. We call that printing or pretty printing. So to add to the operations that we've seen already, we've seen compilation, evaluation and so on, we've also got parsing and pretty printing. So there's a lot of things going on with structures. Things that transform structures, build structures from a serialized form, turn a structure into a serialized or printable form, and so on. And what we're going to do in the next section of the masterclass is concentrate on a particular sort of transformation, and that is pretty printing. And we'll see that's a very good example of how to use recursion over these sorts of structures.